All right, good morning, class. This is Mr. Eggleston, and this is the 5.1 through 5.3 review for the quiz coming up on this coming Thursday. The quiz has 1, 2, 3, 4, 5 questions. Question 2, well, one of the questions is going to be, given this function, graph the equation, all right? So you're going to have to come up with the graph. This one is to write an equation of the exponential function model in the table below. So remember, I'll have this on the board, but the exponential equation is y, that's too fat, is y equals a times b to the x, where a is the value when x equals 0. So looking at our table, and then b is the what we multiply by. B is the common ratio, or the growth factor, or decay factor if it's going down. It's the base of the exponential. So to find b, it's fairly straightforward. Notice that x increases by 1, and if you look at this, y multiplies by 2, because it's an exponential. We know it's got a common ratio. We're not adding the same number, we're multiplying by the same number. So that instantly tells us b equals 2. So we know y equals a times 2 to the x. All right? What we don't know is what a is. Well, if we're multiplying by 2 each time, notice, by the way, that we skip 4 when we go to 5. So you're multiplying by 2 twice. So 4 times 2 is 8. So if we had this 2 right here, if x was 2, the value would have been 8. And then, I'm sorry, not 2, but when x was 4, the value was 8. So when x is 5, it's going to be 8 times 2 is 16. So we're multiplying by 2 going to the right. So we can divide by 2 each time going to the left. So when x is 1, 2 divided by 2 is 1. And then when we go back one more time to 0, which is what a is, that's the value of a is the value of the exponential when x is 0. When x is 0, we divide by 2 one more time, and it'll be 1/2. Because 1 divided by 2 gives you 1/2. So if you look at this, 1/2 multiplied by 2 gives us 1, multiplied by 2 gives us 2, multiplied by 2 gives us 4, multiplied by 2 will give us 8 right here in the middle at x equals 4, and then multiplied by 2 we get 16. So that tells you a is 1/2. So our function would be y equals 1/2 times 2 to the x, and that's the equation. Okay. Now, consider the exponential function this, right? F of x equals 3 times 2.5 to the x minus 4. And it says to graph the equation. Well, to graph the equation, you need to realize, hey, first of all, your grid does not have anything on it. It's just axes. So you look at this, automatically tells you there's a horizontal asymptote at y equals -4, because the whole graph is shifted down. So that's the asymptote. So we can go 1, 2, 3, 4. We know there's a horizontal asymptote. I'm just going to draw a straight line, then I'm going to move it down. A horizontal line. That right there is the asymptote. As a matter of fact, I want to change it to a dashed line so you understand that's the asymptote. All right. Now, it says find the y-intercept. Well, that's pretty straightforward. The y-intercept occurs when x is 0. So we plug x equals 0 into this. That's 3 times 5 to the 0 power minus 4. Well, to the 0 power means that 2.5 is 1. Use a calculator. So this is 3 times 1 minus 4 equals negative 1. So we know the y-intercept is sitting right there. Now, all you really need to do is go 1 to the right. And knowing that this is growth because the base is greater than 1, so we know that's exponential growth. That means it's doing this. If we plug 1 in and just evaluate the function f of 1, which would be 3 times 2.5 to the first. Use a calculator, guys. Minus 4. I want to do it without. So 3 times 2.5 to the first. 2.5 to the first is 2.5. 3 times 2 is 6. 3 times 0.5 is 1.5. So that's 7.5 minus 4, which equals 3.5. So when x is 1, we're up here at 1, 2, 3, 4. We're right here in the middle at 3.5. All right. So when I grade your quizzes, I'm going to look for the correct y-intercept, the correct value when x equals 1, and also the correct y horizontal asymptote, or asymptote. They just call it asymptote. It's really a horizontal asymptote. So I'm looking for those parts of the graph, and then you just connect the dots with a curve that you know it should look like. So I'm not going to be too stressed, but I'm looking for something like that. Notice it's curved. Again, my focus will be on 1 point, 2 points, 2 points, 3 points. All right. So there you go. Identify the domain and range. Well, the domain is easy. For exponentials, domain is going to be all real numbers, always, for exponentials. The range is going to be, as you can see, our horizontal asymptote is y equals negative 4. So you know that the range is going to be y is greater than negative 4. And there you go. All right. Again, the asymptote's pretty easy because all you have to do is look right here. Well, you can't really see that. Right here, and if there's a number being added or subtracted on the back end of the exponential, that's the asymptote. In this case, the asymptote's at negative 4. Okay, that's all I'm looking for. And if you wanted to verify that this is correct, that it has that basic shape, we can actually use Desmos to graph it. So y equals 3 times 2.5 to the power of x minus 4. And you see there's the graph. And if I graph the asymptote, y equals negative 4, you see the graph approaches it. And that's pretty much what we had. We had this point, and we had when x is 1, which is up here. Actually, right about there. So, and it looks like it's right in between. So anyway, that is number 2. I'm not looking for perfect graphs. I'm looking for the correct behavior. All right. Which statement models an exponential relationship? Well, remember, exponential relationship means values are proportional. Values are proportional. What does that mean? Well, if you look at some of these statements, like Jasmine's car uses 1 gallon of gas every 28 miles, That's a slope. That's a rate. That's change. You're adding the same amount of same value of 21 for every 28 miles. The weight of Deanna's grandson is increasing at a rate of 0.3 pounds every month. Again, we're adding 0.3 pounds every month. That's not exponential. Thanks to smart eating habits, Deanna's weight is decreasing at a rate of 0.5 pounds every month. Again, that's a set amount that we're adding. We're adding negative 0.5. The D is the correct choice because it talks about the number of bacteria in a petri dish doubles every 12 hours. That means every 12 hours we multiply by 2. That is an exponential. Okay? On number 4, this is probably the trickiest for you guys. This one's a little bit easier than what you're probably going to have, because on the one you have, you won't be given the zero term. Here they give you the zero term. Okay? They tell you f of x equals a times b to the x. That's what we're focused on. So f of x equals a times b to the x. So f of 0, if you plug 0 in for x, that's going to be a times b to the 0, which is just a. And we know for x equals 0, the value of the function is 60. So that tells you a is 60. That's why this was easy, because a is 60. So now we know our function is going to be equal to 60 times b, the base, to the x power. What we don't know is what b is, and we're going to have to think about this. So we know that starting at 0, we're at 60. Then we multiply by, then when we go to 2, the value f of 2, which equals 60 times b to the second, must equal 15. All right, that gives us an equation to solve for b. So divide by 60, you got b squared equals 15 over 60, which is 1/4. So b equals the square root of 1/4, and it's plus or minus, but we'll talk about what that means. So that's going to be 1/2. All right, but since our base, we're gotta make an assumption, our base is positive, so b is not plus or minus, b is 1/2. So now we have b, we have a, we can we know that the value, we know the equation will be f of x equals 60 times 1/2 to the x power. So if you want to know what the, when x is 3, it's going to be 60 times 1/2 to the third power, which is 60 over 8, which is 4 goes into 60 15 times, 15 halves. You can leave it as 15 halves, but so m would equal f of 3, which is 15 halves, or 7.5, and p, which equals f of 1, is equal to 30, because it's 60 times 1/2 to the first power. So we got p and we got m. All right, and write the equation. This right here is the equation. This was the equation evaluated at x equals 3. So this is actually f of 3 to find m. Okay? So, now moving on. The last question on this quiz. Which could be the equation of this graph? So this graph is exponential growth. Okay, we know it's exponential growth because it has the shape, it blows up moving to the right. So that's exponential growth. which means you know your base has got to be bigger than 1. And also this is exponential growth, and notice the original function would have been something like this. All right, where that's 1, 0, 1. But now it's down here. Actually, it's down here at some negative value. Okay, so we're looking for a horizontal asymptote that's negative. And when you look at these, there's only one that has a horizontal asymptote that's negative, and it's B. Because that is where that number right there, that's a horizontal asymptote. Y equals -1. So that's the correct choice. That is your quiz. I took off any application because we didn't get to it, but I will be making you do it in homework and stuff as we move on, so you'll get the application. It's not really that hard. Understand that if you're looking for a graph that's exponential growth like this, because it blows up to the right, you know your base B is bigger than 1. So the base here, that's bigger than 1, but it's 1 plus, so it moves up. Also, it's a negative exponent, which screws things up. The only one that has a negative horizontal asymptote, or asymptote at this stage, is right there, because you're shifting the whole graph down 1 unit. All right, that's your quiz. So I hope this review was useful. Have a great day.